So good morning. I like security. I like finding out how things work and how to break them. And usually that is followed by finding out, okay, this is how you break them, and then this is how you fix them. And that's the reason why I get a salary, because I like fixing things as well. So this presentation, I've been with Apple for 2.5 years now. Came from Cisco, like you just heard. And DDoS security is interesting. It goes up and down in waves. There was a lot of things happening a few years back, then it got a little bit quiet, then it came up again, and so on. And the reason for this is that DDoS has now become a tool for stating your opinion. If you don't like someone, you attack them. If you are playing an online game and you lose, then you attack that guy because he must have been cheating or whatever. So DDoS is used for all kinds of things now. But when I was creating this presentation, I was going to go for the nice, fluffy one, good to hear in the morning while you drink your coffee and wake up. But based on what has been happening in the last 2 weeks, I decided to change the angle totally and try to explain this really serious situation we are in now. And I would say, unless we do something, and then unless we start working together, I mean, you guys, you service providers, start to help us to solve this problem, this could be really, really serious. So, let me begin by asking you a few questions. 7.7 million. What does this number mean? Beers? Number of beers drunken yesterday? No, that's a little bit too much. 7.7 million is the number of IoT devices connected to the internet or to an IP-based network on a daily basis. And during my presentation, about 160,000 new devices will come online. And almost all of those devices have no security. And I mean no security whatsoever. Okay, we're talking about light bulbs, things which can change colors back and forth. You don't need security on those because they're behind in your network, they're behind firewalls and so on. Or, yeah, you thought. The bad guys, they know how to read basically everything and anything now these days. So keep this number in mind. 1 to 500,000. What is this number? This is the DDoS amplification factor for something called the memcached service, which has been all over the news in the last days. Meaning, if I send 1 byte, or actually 1 packet in this case, to the memcached service, I can make it send out reply with 500,000 packets. Actually, to be more exact, I tested this in lab, 516,436 packets, which is a lot, and I'll go into a lot more details in a second. But this is crazy, totally, absolutely crazy. Another number, 31.4%. Okay, I'll tell you. This is the number of ASNs around the world which allow people to send spoofed packets, meaning their customers and devices on their networks are allowed to fake the source IP and send out packets to the global internet. Almost everyone in Europe, and especially you guys, you're really good at this. Really good at fixing this and not making sure your customers are doing the right thing. So that's good. The problem is people in certain other regions of the world, Eastern Europe, Asia, and so on and so on. And there are some exceptions around Europe and the US and South America, but because they don't care. And the thing is, I'll come back to it a little bit later on, but if we could solve this, then reflection-based DDoS attacks wouldn't exist. Because this is the basis of sending a reflection attack. I pretend to be him, and I'll call and ask for 1,000 pizzas sent to his home. That's a reflection attack, because I'm faking your identity. If I could fix that, well, you'd have to order your own pizzas. And that makes more sense, or I can only order pizzas for myself. The biggest DDoS attack seen on the internet, and this happened February 25th. And this was using the memcached service. 1.7, if someone hits you with 1.7 terabits of garbage, you have a problem. Everyone has a problem. The good thing is this attack was actually mitigated, because if you begin to go into technical details of memcached, it is not that difficult to mitigate. But it shows you how quickly and how aggressive the attackers can be when they see a new opportunity to take advantage of it and then use it. So, because this number blows basically everyone away. And it's so easy to implement and to use. So, how did we get into this mess? Well, number one, the attackers, they come in many shapes and forms. These are the clever guys. These are the ones who come to these conferences, like this one, sit in the back. I'm not pointing you guys out, but they sit in the back. They really understand how the internet works. They look at new release, they examine the code. They take a look at the operating systems. They look for vulnerabilities, and then they create tools. They really go into the business of developing new ways to attack infrastructures and systems and so on. And they do live field testing. And I'll have 2 examples of that a little bit later on. But these guys, they never attack anyone. They manufacture weapons for others to use. These guys, I would like to call them the DDoS mercenaries. Those are the ones who run the booter and stressor services. I still don't understand why people actually believe that's a sane thing to do with booter stressor service. But they actually sell DDoS services to anyone for what? What's the going price now? $5, $2 to launch a gigabit attack against someone? I have no idea. It's very cheap. The only thing you need today is a Bitcoin. Well, not the entire Bitcoin, that's too expensive. A tiny little fraction of a Bitcoin, and you can launch a DDoS attack against anyone at any point in time. And then you have the attackers, that is the ones who actually have decided to attack you or someone else, and they either use the DDoS services or they buy the toolkits. I'll go back a little bit. Toolkits from the guys at the top. So the guys up here, the clever guys, they just create the weapons. They sell them to the booter stressor guys, or in some cases they sell them directly to the attackers themselves. So it's interesting. And okay, we can go into all kinds of discussions. The guy who creates a weapon, should he be put in prison or not? Okay, that's a different thing. But this is how things work. And also, they are very persistent. And attacks come in waves. So if we take a look at this, we have lots of attacks happening, like what was happening with Mirai back in 2016. The attackers, they got tools to actually activate all those nice IoT devices, and they began to launch attacks against everyone, took down the east coast of the US, and so on, all kinds of cool things. We tried to resolve the problem. We tried to understand how this worked, what we could do to do this, and we tried to prepare for the next wave. Because the thing is, when the attackers see that their tools are not working as well as they should be, they of course go into research and development. Because they find out, okay, my attacks using a normal webcam, IoT device, whatever, it is not capable of taking down the services as well as they would want to, because the good guys, that is we begin to understand how to deal with this. So they go into research and development phase, come out with new approaches, new technologies, package them, create attack toolkits, and we just try then to survive the next wave. So it goes like this. We have peaks, valleys, but the trend is upwards. And time-wise, we are somewhere around here. And the reason why I say we are somewhere around here is because we've seen a lot of this happening in the last year. New technologies, new attack vectors being tested on the internet and not used. And they don't disappear. Someone took them and actually has packaged them into something which can be used, that's used in the future. So, one example. Mirai, That is what was used for IoT devices back in 2016. And the primary way for these guys, what Mirai did, was to use brute force username and password hacking, try to connect to devices connected directly to the internet, and then gain access to those. And that was primarily webcams and other things, because people, well, normal people, they don't understand that it's risky to connect stuff to the internet. Actually, don't have the number here, but the situation that it is today, if you connect a vulnerable IoT device to the internet, it takes about 2 minutes. Back in the old days, for you who remember Windows XP, it was 3 minutes for a Windows XP computer to get infected. That is before Service Pack 3. IoT devices are worse than Windows XP from a security point of view. That is unpatched XP. It takes 2 minutes before someone else owns it. But the attackers understood, OK, 5% of IoT devices are on the internet. 95% are actually behind some kind of firewalls, and you will not detect them if you scan the internet. So what did they do? They implemented what we call the Windows Mirai seeder, which is basically a Windows Trojan containing the attack and infection code for Mirai, meaning that you go to a conference like this one, you connect to this Wi-Fi which we have here, someone infects your computer, you take it back to your network behind the firewalls, and it begins to infect all the IoT devices which you thought were secure behind the firewalls. The interesting thing, this didn't happen because this was only live for 2 weeks back in 2017, and then the attackers pulled it back. They disabled it, and we haven't seen that happening real. So I would say they were doing a field test, seeing, does this technology work? We don't know if they were happy or not, but what we saw is actually this, is that when this one came, the next generation, it actually contained the same code or same technologies like the Windows Mirai seeder. So they came up with someone came up with a new attack tool, which is called IoT Reaper, which used the same technologies like the Windows Mirai seeder. So they paid attention and they implemented it in the next generation. So this one is even more scary, because this is not just taking advantage of username and password like root, admin, or whatever. It uses vulnerabilities in the IoT software itself. Buffer overflow, that is sending URLs which are too long, or // or whatever. All those things we have fixed on Linux and Windows servers many, many years ago, but are still a problem on IoT devices. So it's taking advantage of all of those things. And the reason why this made the news is that this became live. They went out there, and at one point, they managed to identify and put into a database more than 2 million vulnerable devices. They were scanning, identified those devices, put them into a database, and which we believe was a queue for infection. These were devices which we could actually take control of. But they never infected more than 30,000 devices. And then they went quiet. So they killed themselves, went offline, and we believe they were actually testing this, the solution for actually scanning, infection, vulnerabilities, and so on and so on. It had a DDoS module, which was empty. It was there, but it didn't contain any code. It was just, here is where we'll put in our DDoS code. And this could be updated online, real time, and had everything in place to become a really efficient tool. But who was developing it? We have no clue. And then we come to this one, memcached. For those who don't know what memcached is, it's basically a memory database caching service, often used by web services and so on. With this, if you want to access something from a SQL database, you retrieve it once and then you store it in memory, because then it will be a lot quicker to retrieve it. The thing is, the default implementation has absolutely no authentication whatsoever. Anyone can connect to it. And in many cases, deployed as listening on all interfaces on the server, on UDP and TCP. Which if you are someone who is operating our cloud service or implementing a solution for a bank or someone, then yes, maybe you do this because you need to be able to access this cache from multiple computers. But then, so you should at least try to protect this. But people don't think that way. And this is the reason why we got up to 1.7 terabits. When the attacks began, there was an estimated 100,000 of these servers out there, open to the public internet and could be abused in this way. So let's go into details. And I'll try to explain how you actually do this. This is a script using Scapy. It basically creates a spoofed IP packet, a UDP packet in this specific case. And as you can see, it's sending the command stats. So you just open a connection to that server. You need to have these headers in place. These are the telling some sequence numbers and stuff. But then you get this back. And that is basically a factor of 1 to 19. If you take a look at the packet sizes, that is 60 versus 1,170. So that's the normal. That's something what we'll see similar to NTP, DNS, and so on. But if you want to become clever and do cool stuff, then you actually inject your own keys. Because, like I said, there's no security. Anyone can inject a key into this database. And the maximum key size is 1 megabyte. So here's an example. Payload is, this is a very long key, can't be up to 1 megabyte in size, and here you can see how this actually works. I just inject it, and I get back a positive answer saying stored. This key has been stored. If I want to create a 1 megabyte key, then I can either use TCP or I can actually use the append command. So I can send the maximum size of a UDP packet, and then I just append until I have the key which is 1 megabyte in size. Okay, and then I'm going to use it. So the key is called A, and there's 1 megabyte of basically junk. So here, the command I do is basically get space A, space A, space A, space A, space A, and so on and so on, 729 times, because that's the maximum you can fit into one UDP packet. And what will happen now is I basically send this one packet to the service, and this is the result. I send one, size 1,513. It says QRC here because I'm spoofing the destination port of the, I'm sending the source port looks like port 80 on a server. In this case, I'm using memcached to attack a web server somewhere. And as a reply, I get 536,302 packets. I didn't count them all. I just used the statistics which I saw on my network. But one packet from an attacker can result in someone else, you, receiving 536,000 pizzas or whatever. That's a lot. Any device in the world can send one packet a second, because this actually translates into 6.2 gigabit of traffic. So I send one packet. I can send from an iPhone, I can send from a light bulb or whatever. And it will result in that server generating 6.2 gigabits of traffic. And then I send another one. And then I send another one. And so on. And that becomes interesting. The only bottleneck here is the size of the internet connection for the servers or for the data center which the server resides in. Because this will fill every pipe in existence, if you're a little bit clever. And this is how it looks like. Get A's, lots of A's, and here's what's happening. This is cool. And as you saw, how many lines of Python code? 10, 15? Any idiot can do it, and of course someone has actually created a tool now which can actually download and click a button and you will launch an attack. So anyone can do this today. And here's, so someone came up with said, but basically there's actually a kill switch, like they would call a kill switch, which in theory should be able to stop this attack. Now I have a question for you. If you're being hit with a DDoS attack, And the technology allows you to fight back or limit or stop the attack in some way. Should you do it? Those who think it's a good idea, raise their hands. Are you all asleep? No one? Good, because the answer is definitely no. I was trying to bait you. The reason for this is, if you're fighting back, if you're sending a command back to the attacker, then the thing is, the attacker is in almost all cases abusing someone else's system. So if you're being attacked by what looks like him, and you send a kill switch to him, I don't care because I was attacking you. I was sending spoof packets to him, resulting in him sending attack packets to you, and you just caused his system to crash. Okay, maybe it was not working very well because it was being used as a DDoS vector, but you are basically taking him offline. And he's also a victim in this case. And yes, there are laws, and I live in Norway, which actually go directly into this. You're not allowed to influence or cause problems with the operations of a computer system. And you would be doing that if you're fighting back. Yes, there are some discussions back and forth, but if you do this, well, if you're fighting back, would you use your own source IP when fighting back? You should do it. If you spoof it, then that's the difference between you and me. Basically none. So don't do it. And the thing is, this is falling off. We have ways to solve. We can defend against attacks. And there have been multiple instances of people coming up with ideas. We could do this. If I'm being hit with a TCP flood, I can send back Windows quench commands and all those things. It's a very slippery slope and will only lead to bad things. Because the scary situation is, if we begin to fight back, and especially if we get automation into this, then in the end we'll have basically full-scale wars on the internet, one system attacking other one, which is then fighting back to stop the other one, and it will be a total, absolute mess. So if someone says this, then say definitely no. It's a very, very bad idea. It will not help you. It will not solve the problem, because the attackers will just come up with a new way, and will just make things a lot worse. And it's immoral, and then and plain stupid to do this. So what are we doing today regarding this? How are we to defend this, solving this? Number one, the general public. Well, they have no clue. Basically, they don't understand security. They will always buy the cheapest solution available. If you go into a store and want to buy a webcam, and you have one webcam for 1,000 Swedish krona, and you have another one for 1,200 Swedish krona, and the only difference is that one says secure, you'll of course buy the cheap one. It gives you the same thing, you get the picture. If it gets used by someone else, well, you don't know. And maybe it will misbehave once in a while it's launching an attack against someone, but you don't care. Then we, the experts, number one, developers are often, they don't understand security. They're getting better at this, but they're very bad at network security. Solution designers, the ones who create those solutions from the different components, they often don't really understand those things. Like if you build a solution using a caching service and you open it to anyone on any ports, maybe you should tell the security guys, please block this port. But no one has told them about these things, and they don't often think in these ways. And here's the worst one, basically. There's a number of service providers and hosting providers who do not care. And when you ask them, you say, well, no one is paying me for this. Or, actually, like in one specific case here in Europe, then there was this hosting provider which sells VMs. That's basically, you can run your VM at their location. And it's extremely cheap. You pay $5, $10 a month or something. But they charge you for the bandwidth, which you use. In this specific case, they were told by a security guy, which I know, that in the data centers, there were a number of memcached servers which are actively being used to launch DDoS attacks, outbound DDoS attacks from their data center. And they said, basically, I don't care. I get paid per byte outbound. So in this case, someone has deployed his VM in this specific data center. He forgot about the security. It is being abused, such as launching a constant 1 gigabit outbound traffic. And the only way that guy will detect this is when he will get the bill from the hosting provider for a ridiculously high amount. Because the hosting provider makes money by having, in this case, the systems of the customers being attacked and abused. That is not good, basically. But some people think like this. And also, and this also goes back to the spoofing and so on and so on. The good thing is, the Nordics and we are pretty good at this. So, what can we do? The solution is, as usual, it's basically hard work. You have to do some things. And number one, get rid of spoofed IPs. If we can do that, we'll solve the reflection problem. Memcached wouldn't exist as an attack vector if we would get rid of spoofed IPs. Like I said, you are doing that, mostly. You have to protect your own networks. You have to scan your own networks. You have to scan your customers. You have to make sure your CPs are OK. There have been a number of service providers who buy cheap CP devices from somewhere which are then being used to launch attacks. We just had a customer in Africa where the entire network was down because the CPs, the customer CPs, which the service provider deployed, were all busy generating DDoS attacks, and basically their customers couldn't get online. So the entire network was down because they had, well, bought the cheapest CPs available and didn't update them. And here's the main thing. Requirements. Make strict requirements of yourself and also of your peers. And I know this is new. If someone wants to connect to you, and you know that their system is full of bad stuff, and they don't care about spoofing and so on, should you really pair with them? Or should you actually increase the charges? Pay me more, because I know you will be sending garbage in my direction. And this is an example. This is actually, you know this guy. I think he was presenting here last year. This is their policy. They implemented rate limiters on all external-facing interfaces, also including customers, because they don't trust their customers. So in this case, this is an example of how you would basically rate limit all the most common DDoS attack vectors, NTP 1919, and here memcached 11211, and they apply it to their customers, they apply it to the peering and so on. And this basically ensures, number one, they won't have a problem. And if their customers have a problem, they're not generating terabits of garbage go outbound. If the customer says, no, I need to be able to send terabits of NTP traffic or something, OK, fine. Charge him 10 times whatever, because it will be abused. But this is the default policy which they have in place. And I think if everyone would start thinking in these ways, make requirements, block things, we will be a lot better off. We need to start to become critical of what's happening. Because the attackers are very clever. The attacks they're generating are becoming more intense, they're becoming more powerful. And if we continue to think everything has to be open to anyone and we don't care who is sending us attack traffic and so on, then we will basically have, the problems we have will basically increase. So we need to become a lot more skeptical and maybe like it was said at the bottom, make requirements of the ones you peer with, which you connect to. More information on this. This is our security report with all kinds of graphs and details and stuff which I didn't cover. Questions? Thoughts?
So we have time for one quick question for Steinthor.
Hello. This is Mem at NetNode. I just have a comment. When you talked about these webcams that you buy the cheapest one, you say that people doesn't care. I think that's a bit rude. I think that people doesn't know.
they don't know, and there's also, okay, Alex, I'll sort of agree with you, but there's also, we don't explain things to them. People don't realize the risks of buying bad things. People buy cars today with brakes. You couldn't sell a car to someone with no brakes. And again, the reason why you have to have brakes on cars is because there's a regulation for that. But I'm not going to talk about regulation of the internet now. That's a really scary thing. But still, people at least understand they need to have some kind of security for almost everything except IP-based devices. Okay.